So this is my design. Starts allotted here so that the water can easily flow through it, pass the nutrition to the roots and have a constant contact with the roots. This is the part, the main body part where you can fit this pothole inside. And basically, if you wanted to do a DIY hydroponics, you have to go and buy a 8-inch PVC and cut it. You need a hard gun, you need a axe blade, and you need a marker, and you need a water bottle. I mean, water in sense glass bottle to do this sort of hole. So, with I'm trying to simplify it in a way that you just 3D print it and go straight into doing your hydroponics thing. uh, a mechanism where locking mechanism where you can just close two things easily, like you can enclose two things easily using this slot thing. And same here, there's two. One is like kind of a male thing and kind of a female thing. This is the inner part that comes inside, and this is outer part. This comes out the side. And this is a 10 mm length. This area is 10 mm, like this to this, and the same goes here. This to this is 10 mm. Both are easy locking mechanism. You don't need any screw type to screw it. Just print it and lock it. So this is a 7. This is designed for a 7 mm water tube, and the water comes here and right to the from the pipe and goes here. And we have, let's say, let me start the analysis. This water comes here and goes here, and it goes through this sapling. I mean the pothole, and it, it it drains to this area. Like it comes like this, and it the water touches the plants and goes like drain like this. Like the down part drains it. So this is what I did. So the reason I gave this slotting mechanism is where you can add up. So you can add up as much hydroponics array you want. Like you can just 3D print this. If you want two, you can 3D print two components and fix it. So if you want three, you can 3D print this main body, three components and fit, and take this female dummy here and put this male dummy here. That's it. So this as simple as that. That is what I wanted to design. So something like this you can do, where we can connect one after one and make a series of hydroponics pots, like these slots you can make. And so that's it. It's very simple. Where let's say this has some like 60, I think 60, total 90. So I suppose it's something around 30 or something. Yeah, 30. So where see, we have this motor kind of model where the water is pumped and is sent to a 7 mm nozzle, where it is yeah. So some from straight away from top we are uh, sending the water through some dia nozzle. Okay. So we are pressurizing the water, so it goes right away and goes, and it flows throughout this loop and comes out of this pipe. So comes right here, and it flows right through this pipe to this, and yeah. So it goes until it comes back. The water comes back from this, drains and comes back to the pool itself, the water pool itself. So that's the thing. The reason I gave the slot mechanism is because when you 3D print it, so when you 3D printers, you cannot print above 0.2 mm of layer height. So this thing you can go with 2, 3, and print it as much first you want. Go with the 60, 75 mm per second of printing speed, and we'll have no issue with that. So this is 3D printable, and this thing we have 1, 2, 3, 4, 5, 6. So it's totally 6 components. And if you wanted to make 2 or 3 more hydroponics slot, you can just 3D print this particular component. You can just print that part alone for how many hydroponics you want and fit it. So that's it. So let's go with the PPT session. So I've explained why I took some design decisions and how I came up with such design decisions and where this can be used.
சின்ன சேனலுக்கு எதாக இருந்தாலும் அது கொஞ்சம் ஆதரவு கொடுங்க. உங்கள் பொண்ணான கையை கொண்டு அந்த பெல்லில் தட்டிடுங்க.